Reliability-centered maintenance, RCM, is a systematic approach to identify and prioritize the most critical equipment in industrial plants. This process is based on evaluating failure consequences, likelihood, and detectability. Criticality ranking is a key process in RCM, focusing on identifying and prioritizing critical equipment in a plant. It evaluates equipment based on potential consequences of failure, likelihood of failure, and detectability of faults before failure. For existing equipment, historical maintenance data and failure histories are used, while new plants rely on design specifications and expert judgment. The criticality ranking process involves 6 steps: defining scope and criteria, collecting data, assigning ratings, using structured tools, reviewing and validating, and finalizing and implementing. Each step ensures a comprehensive evaluation of equipment based on safety, production loss, environmental impact, and cost considerations. Various methods and techniques are employed for criticality ranking, including consequence-based ranking, FMECA, risk matrix, Pareto analysis, expert judgment, reliability data analysis, and multi-criteria decision analysis. These methods are suitable for both existing and new equipment, ensuring a thorough assessment of severity and impact. Key analysis methods in criticality ranking include consequence-based ranking, FMECA analysis, and Pareto analysis. These methods evaluate impact severity across safety, production, and environment, providing systematic identification of failure modes and focusing on the vital few assets. Equipment is categorized into 4 tiers based on criticality: highest, high, medium, and low. Each tier defines the urgency and impact of failure, guiding maintenance efforts to improve plant reliability and safety. This tiered approach ensures focused maintenance on the most critical equipment. The RCM implementation strategy involves prioritization approaches that can be applied in matrix format. Standard practice includes selecting the top critical units for initial RCM implementation, then moving to other equipment as ranked. This strategy ensures efficient allocation of resources based on criticality. For new plants, criticality ranking begins with design parameters and vendor-provided reliability data. It involves failure mode identification, expert panels, preliminary matrix creation, and continuous updates based on operational data. This ensures a dynamic and accurate assessment of equipment criticality. Structured criticality ranking offers numerous benefits, including focused resource allocation, enhanced safety, improved reliability, cost optimization, data-driven decisions, and environmental protection. It directs resources to equipment with the highest impact, prioritizes safety, and reduces unnecessary maintenance. Criticality ranking provides a systematic methodology for identifying and prioritizing critical equipment. It offers multiple methods, tiered classification, and continuous improvement, ensuring equipment is ranked accurately and maintenance strategies are effectively implemented.